Now let's continue to look at another very important quantitative methods that can be widely used, especially within supply chain logistics network type of problem, which is break-even analysis. You guys may still remember that in the last chapter, we already applied break-even analysis when we tried to compare vertical integration and outsourcing when we design supply chain. Now, when we come to supply chain logistic network, we can still apply the core idea of break-even analysis to basically help us figure out what would be the most appropriate site or community to basically locate our factory at, all right, given some financial information. So here, if we know some financial information, such as variable cost and also the fixed cost for every potential site, we can start to apply break-even analysis to figure out the most appropriate location for a certain range of order quantity. All right. So in order to reach that point, we can actually plot out the total cost line for every potential site. All right. And after we plot it out, let's say in one specific X and Y coordination, we can see the overall general picture. All right. That will be basically helping us figure out the general pattern among different potential sites. Right. So with the support of data visualization, we can easily identify the approximate range for which each location has lowest cost. And then, of course, we can use some simple calculation to identify the specific value of the break-even points showing within the picture. All right, so this will be basically the key idea of break-even analysis applied within the supply chain logistic network type of the problem. Now here, I would like to use one specific example to illustrate the core idea of the break-even analysis. As you can clearly see here, within example 2, all right, an operations manager narrowed the search for new facility location to 4 communities, A, B, C, and D, all right? And you can clearly see that within every community, we have certain financial information, including the annual fixed cost and also the variable cost. And all of the information are already summarized within this table, all right? For instance, if you finally decide to basically set up your factory location at community A, then the annual fixed cost will be $150,000, all right? And also the variable cost for every unit delivery to the customer will be $62. All right, so the same idea for community B, C, and also D, although the specific numbers here are different. Given all the information shown here, we can start to use the break-even analysis to help us find out what would be the most appropriate community given a certain level of order quantity. All right, now let me ask you the first question. Suppose we know that our production plan will be 1,000 unit products. All right, so how can we calculate what will be the total annual cost if we build up our factory at community A or B or C or D? How we do this kind of the calculation? Very simple, right? Suppose our production plan is 1,000 units of this specific product, okay? If we build up our factory at community A, what would be the total annual cost? Very simple, right? Basically, you use 150,000, all right, plus 62 times what? That's 1,000 units, right? Because there's a variable cost per unit, which is 62. And since you produce 1,000 units, that's why the total variable cost will be 62 times 1,000. And then you further add up with the fixed cost in order to get the total annual cost, okay? And if we want to calculate the total annual cost for, building our factory at community B, then the same logic here, right? Basically, use $300,000 plus the $38 times the corresponding 1,000 units. Since your production plan now is 1,000 units, okay? So you can repeat this process for, community C and also community D in order to get the corresponding total annual cost. Okay, so if I, try to basically summarize the basic relationship between the order quantity and the corresponding total annual cost by building up the factory on within community A, B, C, or D. Here, I list the corresponding function here. You can clearly see that no matter what is the corresponding order quantity, Okay, basically this is following the function rule showing here, right? Basically, if I try to order 1,000 units of the product, exactly as what we just mentioned, right? We basically plug in 1,000 units into these four specific equations, and in order to get the corresponding four different values, which is representing the total annual cost for building up a factory within that corresponding community. Okay, so basically this is how we basically summarize the corresponding relationship between total annual cost and the order quantity within one specific community. Then, as I mentioned at the beginning of break-even analysis, we want to further use the data visualization technique to help us figure out the general picture of the comparison among different community. All right, then how we basically plot out the corresponding relationship between total annual cost and also the order quantity level within every single community. Very simple. All right, actually here within this slide we already plotted out the corresponding curve, okay, for community A, community B, community C, and also community D, okay, to capture the relationship between order quantity as the independent variable shown here and also the annual total cost as the dependent variable shown here. Okay, so which is exactly reflecting the functional relationship that I summarized here. Okay, then the question would be how we basically plot out the corresponding curve, okay, given the functional relationship that I already summarized here. Very simple. We all know that in order to plot out every straight line within one coordination, we need at least 2 points on that straight line in order to fix it, right? That's actually very intuitive. So here, for instance, if we try to plot out the straight line for YA, all right, how we basically plot it out? Very simple. First of all, it's obvious that when Q equals 0, the corresponding YA value is 150,000. All right, so that's why here, if we go to this specific figure, actually they already plotted out for us. Let's kind of illustrate this. All right, here you see the Q is in 1,000 and basically the Y value is also in 1,000. That's why you see when Q equals 0, what is corresponding value is 150, basically represent 150,000. All right, now let's continue. So here, if we set Q equals, for example, 10,000, all right, then what is corresponding YA value? Very simple. Use 62 times 10,000 and then further plus 150,000 to get the corresponding YA value, right? And then if you go to this illustration of figure, you see that when Q equals 10, the corresponding YA value should be the value that what we just get. All right. And once you have 2 points within the straight line, you can plot it out smoothly. All right, and follow that logic, you can plot out every single straight line showing in this figure. Okay, so this will be the first step that we need to do in order to use the basically data visualization kind of technique to help us figure out the most appropriate community given certain range of order quantity. Now, after we successfully plot out the total annual cost curve for no matter community A, community B, community C, or community D, okay? If you look at this figure, you can clearly see that there are some intersections among different straight line, all right? So we call it break-even point for the corresponding communities, all right? So the next question that we need to further answer is that how we calculate the corresponding break-even point showing within this coordination. Very simple. Now, suppose we're looking at this specific break-even point, okay? And you can clearly see that this break-even point is corresponding to community A and also community B, right? The red line and also the blue line, all right? So how we basically get this value of the break-even point? Very simple. If we go back to the specific, equation that I show here, the function that I show here, okay? The break-even point basically represents the order quantity amount that will lead to the same total annual cost between community A and community B. Then how we can basically get the corresponding break-even order quantity value? Very simple, all right? Here, you know that YA equals 150,000 plus 62 times Q, right? YB equals 300,000 plus 38 times Q. All right. In order to get the corresponding break-even order quantity, okay, so you let YA equals YB. Then basically 150,000 plus 62 times Q will equal to 300,000 plus 38 times Q. Then you can basically solve for that equation in order to get the corresponding order quantity. If you solve that equation, you will figure out that the corresponding value will be corresponding to 6.25. Okay, if you have any question, feel free to let me know. All right, now you can follow this logic to basically calculate all the other break-even point, all right, showing here. Now, after we successfully plot out the corresponding total annual cost curve in one coordination, and also calculate the corresponding break-even point as what we just mentioned, all right? Our next question is to basically interpret the corresponding, results that we show here with the support of data visualization techniques. All right, we want to basically answer in a certain Q range, what would be the most appropriate community for us to build up our factory. All right, here you see that basically, if you look at the Q range between 0 and 6.25, basically represent 6,250, right? If you look at vertically, all right, red line is actually at the bottom. Means what? It means that basically when your Q amount is between 0 and 6,250, all right, then the total annual cost of building your factory at community A is the lowest among all those 4 different alternative community. Okay, that would be a very important interpretation and also the observation that we can see from this figure. Or similarly, if you kind of expand your order quantity, all right, from 6.25 until 14.3, okay, in this specific Q range, if you compare all those 4 different curves vertically, you will see that basically the blue line become basically the lowest curve among all those 4 different curves within this specific range, right? Which indicates that, okay, if your order quantity level is between this specific range, this medium range, right? Then basically the community B probably will be the best option that you can choose in order to minimize your total annual cost through this whole process, okay? Or if your order quantity is, let's say, a high level, which is basically about 14,300 level, then you can clearly see that within this Q range, if you vertically compare 4 different lines, right? The green line is actually at the lowest level, which indicates that if you build up your factory at community C, that will actually minimize your total annual cost through this process. Okay, so after we plot out the corresponding, curve and also calculate the break-even point, okay, and directly by looking at this figure, okay, with the nice support of data visualization process, you can clearly see that when your Q level at a relatively low level, then it's better to basically set up your factory at community A. However, when Q level is actually at the median level, then probably it's better to basically build up your factory at community B, all right? And if Q continues to move up and reach a high level, then in this specific example, probably community C is better, okay? So this example basically greatly help us illustrate how we can efficiently use break-even analysis together with the data visualization techniques to basically help us figure out the key sense of this type of the question. Now, let's continue. So here, I also briefly list a few different steps related to the geography information system methods for locating multiple facilities. Okay, please look through all those steps. And if you're interested about this, feel free to let me know. I can provide you some more information about GIS methods. All right, now let's move to the inventory placement. So we are always talking about the inventory, management through the operations management work. All right. Now here for the inventory placement, since this is also related to logistic, right? Normally in general, we have 2 different ways of placing our inventory. One is called centralized placement. Another one is called forward placement. Very simple. The centralized placement basically indicates that you keep all of your inventory at a single location, probably at the center of your, different customer populations. All right. But the forward placement is different. Basically, you locate a few different, delivery center or warehouse or factory, near to your customer. All right. So as the figure show here, all right, you can clearly see that this will be an illustration for a centralized placement. And this is a nice illustration for the forward placement. Okay. And you can clearly see that within a centralized placement, there is a centralized warehouse locating around middle to serve for all of different customer populations around. All right. However, here, if we use forward placement methods, then we have a headquarters still around middle. However, we set up a few different delivery center which are near to different customer populations. All right. So definitely there are some advantage and also disadvantage of using either centralized placement methods or the forward placement method. Okay. Clearly, if you look at forward placement method, then probably the delivery time will be shorter, and also the transportation cost will be also lower, since you see the straight line distance actually is lower within the forward placement method compared to the centralized placement method. Okay, then what would be the advantage of using centralized placement method? Now, let me give you a quick example to help you illustrate it. All right. Now, suppose you have some demand shortage at C8. All right. While you have some demand surplus at C3. With a one centralized warehouse, all right, this demand fluctuation within different customer population may not significantly affect the overall demand requirement within the centralized warehouse. Okay, and that's also the key sense of the concept inventory pooling. All right, now if we go to the forward placement of inventory, suppose C8 has some demand shortage, while again C3 actually has some demand surplus. Then in order to compensate the demand shortage in this specific area, okay, you have to basically transport some of your inventory in this area back to this specific area. And this will cause some inefficiency during this whole process. Okay, so this will be a full comparison between centralized placement and forward placement of inventories. All right, so which one is more appropriate? It really depends on the product characteristic and also depends on the corresponding geographic information. All right, now let's continue. So here at the end, I basically provide a systematic location selection process. All right, as we mentioned at the beginning, normally the first step would be identifying the important location factors that may significantly affect the basically location facility choice. Okay, we need to categorize them as dominant or secondary factors. All right. Now, after we understand the location factors, then the next question would be basically narrowing down some potential alternative communities that we can actually build out our no matter factory or warehouse at in order to help increase our efficiency. All right. In order to make the quantity methods available, we probably need to collect some data among all different alternatives. And then we can use different type of quantitative methods to help us figure out what would be the most appropriate one according to different type of the information or data that we can collect. All right. If you can actually calculate, for example, some information related to the transportation distance, the transportation cost, we may use the low distance method. If you have some financial data, we may use the corresponding break-even analysis. And also we may use some data visualization technique to help us figure out the general pattern. Besides that, we may also need to consider some qualitative factors that are not that easy to be captured by the specific quantitative methods. And then finally, we will prepare a final report containing site recommendations along with all of the summary of the data and also analysis that we did through all different methods that we just mentioned. All right, here I basically provide another example about the basically supply chain logistic final evaluation. All right, and you can clearly see that within this example, let's say this is a new medical facility. Okay, it will be located in Pennsylvania, every city, okay? The following table shows the location factors, the weight, and also the score. Here, within this table, I basically show the score for this specific site. But of course, we may actually have, the score for every different site according to the corresponding factors. All right. But here, what we're trying to ask is, what is the weighted average score for this specific site? Okay. So this table clearly shows that basically, first of all, we value all these specific factors for this specific company. Okay. For example, total patient miles per month, facility utilization, average time per emergency trip, all these factors are very important for this specific kind of company. All right. And we put different weight on different factors, right? For example, put 25% on total patient miles per month, which is higher than the 20% weight for the facility utilization. Okay. So that's why here you see if you add all them up within this specific weight column, the final result should be 100, which actually represents 100%. All right. The total has to be 100%. All right. Now, this will be the score within this specific factor dimension for this specific site. All right. So basically, in this site, the score is basically 4 according to the total patient miles per month, this specific factor. Okay. Then how we calculate the corresponding weighted average score? Very simple. Actually, we already showed the corresponding process, right? In order to calculate weighted average score, basically, we need to multiply the weight with the corresponding score for every row, all right? And then we simply add all them up in order to get the result, which is 340 for this specific site, okay? You can also calculate the weighted average score for some other site, all right? And simply compare the weighted average score among different sites, all right? And probably we will finally choose the site with a higher weighted average score. So these are all the content related to this specific chapter. If you have any question, feel free to let me know. Thank you.